Welcome to this video on architecting private AI agents with local inference, presented by the creators of YPipe on the MLcon conference in Munich in 2026. In the following, we summarize the presentation slot. As consultants and software engineers with deep experience in big data and cloud infrastructure, our focus is on fitting the right technology to the task and simplifying data access. This segment covers how model context protocol tool calling works and details its underlying data privacy implications. In the tool calling initiation, the user submits a prompt to the LLM. The context window includes the descriptions of all docked MCP tools. The LLM formulates a tool call snippet. An orchestrator, like Spring AI's chat client, detects if the LLM formulated a tool call. The MCP client issues a tool call, which communicates with the MCP server over standard I/O or RPC protocols, which executes the code of the tool like an enterprise database query. The MCP server returns the response to the client, which sends it to the LLM. The LLM then uses this data to compose the final response in Markdown or JSON. When the MCP server fetches sensitive data from your database, that full dataset is sent over the network to the LLM provider, like OpenAI or Anthropic. We are exploring what's in this tool's call chat cycle in practice, including log analysis and chat completions within our system. We can see that the user's prompt, the SQL query, and the query results is completely sent to OpenAI.
When dealing with data privacy, we must be aware of how platforms retain inputs and outputs, and the importance of adhering to usage policies.
To prevent this data leakage, we decided to build a local, sovereign AI architecture, because compliance laws like the GPDR prohibit sending sensitive enterprise data to cloud LLMs. To make our solution viable for businesses, we established strict requirements. It had to be fully no magic in its execution, DevOps compatible, and simple enough for non-technical users to run. Although we initially tried building on top of a llama, it proved to be too slow and unpredictable, so we pivoted to writing custom integrations directly on top of llama-CPP to achieve a fast, stable, and secure local runtime.
Local AI is becoming an imperative for token efficiency, compliance with regulations. Beyond privacy, we want to save token costs and network latency. Sending large data batches over the internet forces us to pay cloud providers just to leak our own data. For repetitive business tasks like data engineering, we move the compute closer to the data using small, local models. Additionally, local AI protects us from external geopolitical risks. Relying on cloud providers means foreign jurisdictions can instantly block our access via export bans or sanctions. Finally, running locally eliminates model drift and censorship, ensuring our models remain consistent and behave the same way from one day to the next.
Our journey with YPipe has evolved from an integrated solution for orchestration to a focus on multi-MCP docking capabilities. In this first live demo, we look at running small models and maintaining uncensored chat capabilities locally. Here we see how different model sizes perform when calling various tools. As this graph shows, there is a clear trade-off between model size and tool calling reliability, often influenced by the hardware you are using. When implementing local AI, common failures include context pollution and execution errors, which can lead to critical issues like endless looping or hallucinations. Furthermore, for a non-IT user, even the installation of MCP runtimes like Python, Node, or Inference engines is complicated. To address these challenges, we implement solutions such as contained runtimes, automated MCP retrieval, and robust recovery nodes. Our second live demo focuses on making MCP server management as easy as possible. We provide a look at our interface, which streamlines the handling of features and configurations for your MCP servers. Looking back on our journey, we started with an integrated solution, followed by developing multi-MCP docking capabilities, tweaked parsers, and MCP server extension. This approach highlights the core components of our architecture, designed for simplicity, auditability, and predictable performance in multimodal agentic flows. In this final demo, we showcase our agent builder and demonstrate how we deploy these flows effectively. We enable the building of agentic flows with specific LLMs, offer multiple integration options like MCP or REST, and look forward to Kubernetes deployments.
Moving forward, we are focusing on DevOps and intelligent multimodal flows, and we are eager to explore co-innovations based on your specific use cases.
Thank you for watching. We invite you to reach out with any questions as we continue to build sovereign AI together.